So now we want actual information on the glider that we're going to use for this flight. Let's use a very basic training glider, Schweitzer 233A. Alright, and basically in whatever glider you use, you can look up in the manual performance curves, and you'll always get something like this, and the curve is going to change a little bit based on your weight, but you'll always get, the same kind of shape, where you'll get a graph based on your speed, or airspeed, and you'll get a point at which you've maximized your lift to drag ratio, which is essentially, like, let's say you're gliding along like this. It's a ratio of the amount of altitude you lose, the amount of altitude that goes down per distance traveled. Actually, that would be your sinking speed. The lift drag is the other way around. It's how far you go per distance lost. So if you have a glide ratio of, let's say, 30:1, that would mean you travel 30 units long. It doesn't matter. You could think of it as feet or meters or whatever you want. You would go 30 meters long per every 1 meter lost, or 1 unit of distance lost. And this is assuming you're not in any lift or sink. This is just in basically still air. Or it also assumes you don't have a headwind or a tailwind, which that's the point of these calculations that I'm going to show you guys now, is how to take the wind into consideration and to calculate your usable glide ratios. So with SGS 233A, we can look up in the manual that the best lift drag speed is 41 knots. So we're gonna plan on sticking to 41 knots during the flight. So we'll call that our true airspeed, or I'm actually going to use a variable v in these calculations. That's going to be 41 knots. And we know that at this best LD speed, right from the manual, you can see that you will get a glide ratio of 22. Let me write that out a little better. 22:1. All right, we'll call that G. That's our glide ratio. And let's check the weather, and we'll see that the winds aloft in the height range that we're going to be flying, we'll call that W for winds aloft. They're going to be coming straight out of the east, 090, at 20 knots. Okay, so if we look at our flight plan, we can see we're going from basically west to east. So this is going to be a headwind, and that is actually going to reduce our usable glide ratio. All right, let's actually calculate our usable glide ratio, or net glide ratio. Net glide ratio. I'm going to write the formula and then I'm going to explain it. It's equal to the glide ratio times the safety factor times the ratio of the velocity of wind, velocity of headwind specifically, but actually no, V stands for your airspeed, sorry. So yeah, times the ratio of your airspeed minus the velocity of the wind over your airspeed. Okay, now the glide ratio is basically our maximum glide ratio, 22:1. That's what we've found from the manual. But because we want to play it safe, we need to essentially put in a safety factor, which is a ratio that we're going to purposely reduce the glide ratio by for the purposes of our calculations. Basically, and that's meant to account for, non-perfect soaring skills, like maybe you're not good at holding, the best glide speed constant. maybe the glider weared out over time, different things like that you just want to account for. And you can actually change the safety factor depending on your skill level. Let's assume we're going to be beginners here. We're going to use a safety ratio of 0.5 or 50%, right? So let's actually write out the numbers here. We would get glide ratio of 22 to 1. You just write in 22. That's the number we're interested in. 50%, that would be 0.5. Don't write in 50 there. That would be bad. And our true airspeed, by the way, make sure your units are the same. You know, you can use knots, miles per hour, whatever, but make sure they're the same for your airspeed and the wind speed, right? And they are. We're using 41 knots and 20 knots. So 41 knots minus 20, okay? And we're playing it safe here by assuming that the 20 knots is going to be working against us the whole time, right? In reality, most likely you're going to be doing some turns and not working against a 20-knot wind the entire time. But this is, for the purposes of our calculations, we're going to assume this is a direct headwind. So you can do this calculation, and we get a usable glide ratio of 5.6 to 1. That's, pretty crappy. We could probably do better in a Cessna, but, this is just to show you how to do a cross-country flight, so we're going to use that for now. And then the one other number we need, and this is probably the most usable number, remember, we don't have fuel. Altitude is essentially our fuel, right? That's what allows us to travel distances. Remember that triangle I drew before? I don't still have it. But essentially what this is saying is you are going to, for every unit of distance you lose, you are going to gain 5.6 units of horizontal distance over the ground. And this takes into account the headwind and, a worn-out glider. But anyway, we know the amount of nautical miles in each leg. So the most useful number we can have is knowing the amount of altitude we're going to use to travel 1 nautical mile over the ground. And there's a very simple way of calculating this. We just basically want to adjust this ratio so that the amount of distance in a nautical mile is, in the numerator. So the amount of altitude we're going to consume per nautical mile is going to be simply that distance, 1 nautical mile, over our net glide ratio. And actually, if you need some kind of unit of how far you're going to sink in 1 nautical mile. So let's say we want to calculate how many feet we're going to lose for every nautical mile we travel. So then you just put a unit of feet in the numerator. So there are 6,080 feet in 1 nautical mile, and our net glide ratio is 5.6. So because we put feet into the calculation, we're going to get an answer in feet. If you do this division, you will get 1,086. And that is how many feet we will lose in 1 nautical mile of travel over the ground.